Hello, everyone. I'm Andy from ThinkMo. I am currently teaching CCIE courses. From today on, I'm going to share with you CCNA, CCNP, CCIE related technologies. Today's topic is what is BGP. BGP is called the Border Gateway Protocol. Border Gateway Protocol. Then let's briefly elaborate its several characteristics. For example, people often use OSPF or ISAS, or the obsolete RIP. Some dynamic routing protocols like Cisco's EIGRP. They have a characteristic. They all run on the autonomous system class. Autonomous systems are called as autonomous system. So what does that mean within an autonomous system? Between autonomous systems, the OSPF network is as. EIGRP is also called as. Words like ISIS are also AS. So as the network expands in the global network, there may be networks involving carriers, the intranet network of the enterprise, or a network in a data center. The global networks are relatively independent of each other. For example, some national networks, they need to be interconnected. If OSPF, ISAS, or EIGRP is used, not convenient. The second aspect, because of its routing protocol management issues. Let's say network A is connected to, and our router in the middle. Connect to network B. Network A and network B. The middle is connected by a router. In the past, two different networks implements interworking between AS. You can use redistribution. Let's introduce A's network into B's network. I'm going to introduce B's network into A's network to achieve the integration of different protocols, to achieve connectivity. Now there's a problem. The R router in the middle. If you want to make some adjustments to network during maintenance management, that's the kind of thing that comes up. A network administrator. You have to log into this router before you can do it. And the network administrator of network B. Maintenance management is required. Also log into the middle device. Perform maintenance operations. So there's no autonomy. Autonomous systems are meant to be self-governing. It's equivalent to sovereignty. If user A logs into the router, B can't log in. Not if B logs into A. In order to do that. So you have BGP. BGP runs between autonomous systems. You can connect different networks. Different AS are connected. Each manages its own device. Achieve maximum convenience. Have independent authority. Beyond that is its routing protocol. Indicates the routes that can be carried by OSPF. It's about 1 to 10,000. Indicates the routes that ISAS can carry. It's around 20,000. EIGRP is similar to OSPF. So they don't work in a large network environment. Global routing entries. There are about 800,000 of them. It's obvious whether you use OSPF, ISAS, EIGRP. You can't carry it. That's something to be aware of. This is not a performance issue. It's when the protocol itself is designed. The algorithm inside of it. And other convergence problems. The internal algorithm doesn't work. When designing OSPF, I never thought it would be used in a large network environment. The same is true for ISIS and EIGRP. These protocols collectively have limited computing power. It's a congenital defect. So you have BGP in the early stage. The predecessor of BGP is EGP, also known as Border Gateway Protocol. It is a classless routing protocol. So there are classes of routing protocols. and classless routing protocols. I will not elaborate. BGP is an updated version of EGP. You can think of it this way. And then you run BGP. How do you choose the optimal path? Let's say we download something or shop online. The requirement for broadband is to be fast. Basically, low latency and high bandwidth. Then BGP can achieve the feature of fast. This is from the campus network similar to IDC. In the network for the corresponding explanation. That's it for today. If there are any other skills you'd like to learn, feel free to leave a message or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.